In this lesson video, I'm going to show you how you could go about developing a formula or discovering the relationship between the number of sides of a polygon and the sum of the measures of the interior angles of that polygon. Now, just before we begin, really quickly, I want to go over some vocabulary. A polygon is just a shape with a certain number of sides. Okay, and so that's what we're going to be looking at today, is several different shapes. You probably know the names of some of the most common polygons with few sides, like three-sided polygon's a triangle, and a four-sided polygon's a square. Or, well, quadrilateral more specifically. If all four sides are equal, it's a square. 5 sides, we typically call a pentagon, right? It looks like a house, and so on and so forth. And then the interior angles are all of the angles inside of that polygon. Okay, so all of the ones that are contained within the sides. There's 5 in the pentagon, and 4 in the square, and of course 3 interior angles in the triangle, right? And the sum would just be adding them all together. And we're going to discover that there's actually a relationship between the number of sides and how the sum of the measures of the interior angles. So you can see here I've drawn a triangle, and what I've kind of added here in black are 2 parallel lines going through the top and bottom of the triangle. The purpose of that is this is just a brief proof that given 2 parallel lines, I can show you that what the sum of the measures of the interior angles of a triangle are. And that's key because we're going to use the triangle as kind of the basis for discovering the relationship for other polygons and kind of extend that relationship. So as you can see here, I have up at the top of my triangle there the letter alpha, angle beta, and angle gamma. And if you took those 3 pieces, the red, the blue, and the green together, you can see that they form this straight angle right here. And you may remember from Math 1 that a straight angle is worth 180 degrees. You may also remember from Math 1 that if I take this one black side of my triangle and kind of extend it, it looks like a transversal that's cutting 2 parallel lines, right? And we also know that if a transversal cuts 2 parallel lines, something that we call alternate interior angles are congruent. So that means this angle up here, angle alpha, is congruent to or the same size as angle alpha down here because they're on alternate sides of the transversal and they're interior, meaning they're within the parallel lines in this region, right? Not exterior to the parallel lines. Oops. And so that kind of shows us there that those 2 angles would be congruent. As you can see, I did the same thing with gamma. The green gamma is congruent to gamma, and of course beta is congruent to itself. So you can see that if those top 3 angles all add to equal 180, then the 3 angles inside my triangle there, and there must also add to get 180 because they're congruent to the angles at the top of the triangle. Therefore, we can conclude, as I wrote here in this statement, that the sum of the measure, right here, that measure of angle alpha plus measure of angle beta plus measure of angle gamma equal 180 degrees. Or another way to say that is, the sum of the measures of the interior angles of a triangle, in fact any triangle, is 180 degrees. So with that in mind, knowing that all the interior angles in a triangle add up to 180 degrees, let's see if we can try and figure out what all of the angles add up to for other shapes. So looking at this shape here, it's 4-sided. It's a special type of quadrilateral, specifically called a square. I didn't note that, but each of these sides are congruent to each other, okay? And so since we know it's a square, there's several ways we could go about trying to figure out the size of the angles. But what I want to do is draw your attention to the fact that I can actually take this square right here, and what I can do is cut it more or less in half. I don't know if it should make a nice little line for me. And I can actually cut this square in half, basically. And you can see that when I cut the square in half, I'm left with 2 triangles, right? And each triangle has the sum of the interior angles is 180 degrees, right? So the sum of the interior angles of that triangle is 180 degrees, and the same for that triangle right there. And in order to find the measures of the interior angles of the whole figure, right, that entire quadrilateral, what I can do is take 180 and add it to 180, right? And so if I add 180 and 180, I'm going to get 360 degrees. So the sum of the interior angles of this four-sided figure, called a square, is 180 degrees. And that actually holds true for all quadrilaterals, so anything with four sides, any polygon with four sides. Another way to look at it, since I did mention it's a square, that means by definition we have four right angles. And you may remember that each right angle is worth 90 degrees. And so if I took 90 degrees and I multiplied that by 4, or I added it 4 times, whichever is your preference, I would once again get 360 degrees. Let's see if we can do something similar. I'm not sure, I'm actually going to add that back in, that little line that cuts it in half, so we can have that and see, hey, two triangles. Let's see if we can do something similar with our pentagon here. So I'm going to try to do the same thing where I can somehow get equal triangles. So let's see if I draw from this side to this side, there's a triangle. And if I draw from this side to this side, there's another triangle. Perfect. And we can see that out of this pentagon, a five-sided figure, I formed three triangles. And once again, we know that the sum of the interior angles of each triangle is 180 degrees. So all the inside angles add up to 180. What I can do to find the sum of the interior angles of the whole figure is take those three triangles and add them together. And 180 plus 180 plus 180 is going to get me 540 degrees. So the sum of the measures of the interior angles of this pentagon, this five-sided figure here, is 540 degrees. So they all add to 540. What I want you to notice really quickly here is from a triangle we can form one triangle, right? One three-sided figure yields one three-sided figure. What about down here with this my special quadrilateral called a square? I had a four-sided figure which yielded two triangles. Then with my pentagon I had a five-sided figure that yielded three triangles. And if you take note, each time I add an additional side, right, I have basically another vertex there from which to create an additional triangle. And you'll note that there's a difference between the number of sides and the number of triangles that can be formed, right? And specifically, it's a difference of 2, right? 4 minus 2 is 2. 5 minus 2 is 3. And difference means subtraction, okay? So basically, if I know the number of sides that I'm going to have, I can then figure out what the sum of the measures of the interior angles are going to be. And so from that, drawing those triangles is where we derive this formula here that I'm going to show you how to use in another lesson, where n, that number there, stands for the number of sides that the polygon has. So the number of sides goes here, but basically you take the number of sides and you subtract 2, because that thing, the number of sides minus 2, tells you how many triangles you have, right? How many triangles you can make. So that's why that's useful. And then you multiply that number, which is saying how many triangles you can make out of the figure, by 180, which is the measure of the interior angles, or the sum of the interior angles of each individual triangle. And in total, you get exactly what we're looking for, what we call the polygon angle sum, or the sum of the measure of the interior angles of that polygon.